Hey everyone, and welcome back. Ready for another deep dive?
Always.
Awesome. Today we're going to be talking about something pretty wild. Supermassive black holes
Oh, yeah.
and the disks of matter that swirl around them.
Some crazy stuff.
Yeah, so we're looking at some really interesting new research out of Caltech. And let me tell you, it's going to completely change how we think about these disks.
It's pretty mind-blowing.
Yeah,
before we jump into all the nitty-gritty details, we got to remember that we're talking about quasars here.
Oh, right.
They're like the divas of the black hole world.
Uh-huh. Okay, I like that.
Totally.
Yeah.
These things shine brighter than entire galaxies as they just gobble up matter like crazy.
That's a pretty awesome image.
Right.
So these quasars, they're putting on this incredible show, but they're also super far away, right?
Exactly. Like insanely far.
Yeah.
Which makes them super tough to observe directly.
I can imagine.
Think about trying to study a tiny firefly buzzing around on the moon.
Oh, wow.
That's basically what astronomers are up against with quasars.
So how do we even begin to understand something that's so far away and so extreme?
Well, that's where supercomputer simulations come in.
Ah, okay.
And the team at Caltech, they've created this groundbreaking simulation.
Yeah, I read about that.
It lets us basically zoom in on a single quasar and watch it evolve over time.
That's incredible. It's like a time machine for quasars.
It really is.
So this simulation, it combines two different kinds of astrophysical simulations, right?
Yep, fire and Starforge.
Right. Can you explain why that's so important?
Sure. It's like having two different sets of blueprints, you know?
Okay.
One shows you the overall layout of a building,
Right.
and the other one dives into all the details like the wiring and plumbing inside the walls.
Let's see.
So fire gives us that big picture, you know, things like galaxy formation, the movement of huge gas clouds.
Right.
And then Starforge zooms in on those smaller scale events like how stars are born.
Okay.
By combining these two simulations, scientists have basically created this unified blueprint of the universe. It shows how all these grand and tiny processes are connected.
That's amazing. So it's like they built this ultimate cosmic zoom lens.
Exactly.
And what did they find when they pointed this lens at quasars?
Well, this is where things get really interesting.
Okay.
For decades, astronomers thought that the disks of material spiraling around these supermassive black holes were flat.
Oh, yeah, like a cosmic crepe or something.
Exactly. Everything nice and neat, swirling in a flat plane.
Right. I remember seeing those illustrations in textbooks.
Totally. But then observations started showing something different.
Oh.
These disks weren't flat at all. They were more, fluffy.
Fluffy.
Yeah, think more like an angel cake instead of a crepe.
Okay, now that's not what I was expecting.
Right. It was a real head-scratcher for scientists.
So what was causing this unexpected fluffiness?
That was the million-dollar question, and this is where the Caltech simulation really shines.
Okay.
It revealed that magnetic fields, those invisible forces that are everywhere, are playing a much bigger role than we ever thought.
Wait, so something we can't even see is shaping these massive structures around black holes.
You got it. The simulation shows these magnetic fields acting like cosmic scaffolding.
Wow.
They're propping up the disk material and creating that fluffy angel cake structure.
That is so cool. So our old theories about thermal pressure being the main driver were totally wrong.
Pretty much. This discovery really flips our understanding of how these disks work.
Whoa.
And it highlights the huge role that magnetic fields play in the universe.
This has to have huge implications for our understanding of black holes, right?
Absolutely. It changes everything.
Like what?
Like how we estimate the mass and density of these disks, and even how quickly material can flow into the black hole itself.
So it's not just about the shape of the disk, it affects everything.
Exactly. And the geometry, forget about perfect flat disks. We're now talking about warped, lopsided structures, all sculpted by these powerful magnetic fields.
That's amazing. It's incredible to think about these invisible forces shaping some of the most powerful objects in the universe.
It really is mind-blowing.
This must open up a whole new world of questions for astrophysicists.
Oh, definitely. This discovery isn't just about black holes. It's about the fundamental forces at play in the universe.
I see.
I mean, if magnetic fields can have this kind of impact on a galactic scale, what other surprises are out there waiting to be uncovered?
That's a great question. And speaking of surprises, the Caltech team didn't stop there. They used this simulation to explore other astrophysical mysteries too.
Right. They've started using it to study everything from galaxy mergers to the formation of the very first stars in the universe.
Wow.
It's like having this new super-powered telescope that can peer into the past.
That's incredible. So we can actually see how our universe came to be.
It's getting us closer than ever before.
Yeah.
It really makes you think.
It does. So we've got these supermassive black holes at the center of it all.
Right.
It's easy to say supermassive.
Yeah.
But can you help us grasp, like, how massive are we really talking?
It's almost impossible to imagine.
Yeah.
Think about our sun.
Okay.
It's already huge, right? Now multiply that mass by millions.
Whoa.
Or even billions.
Okay, now we're talking.
That's the scale of supermassive black holes.
Wow.
They're crammed into a space smaller than our solar system.
That's crazy.
But their gravity is so strong that nothing, not even light, can escape.
It's mind-boggling that we can even get a glimpse of these things.
It is.
Speaking of which, didn't they release some amazing images of black holes a few years ago?
You're talking about the Event Horizon Telescope.
Yeah.
Back in 2019, they released the first ever picture of a black hole.
I remember that.
The one at the center of galaxy M87.
Right.
And then in 2022, they got an image of Sagittarius, the supermassive black hole in our own Milky Way.
Yeah, those images were incredible. But we weren't actually seeing the black hole itself, right?
Nope, black holes are invisible by nature.
Right.
What we saw in those images was the accretion disk. It's this swirling mass of gas and dust that's being pulled in by the black hole's gravity.
I see.
This stuff heats up as it spirals inward and it emits radiation, including light that we can see from Earth.
So even though we can't see the black hole directly,
Right.
we can see the crazy light show it creates.
Exactly. And all those properties of that light show the brightness, the color, the shape of the disk. It's all influenced by those magnetic fields we've been discussing.
So those images, incredible as they are,
Yeah.
they're just a tiny peek into the even more extreme environments around quasars.
Totally.
These are black holes on overdrive.
Exactly. Quasars are the rock stars of the black hole world.
Uh-huh.
They shine so brightly they outshine entire galaxies.
It's hard to even imagine.
Right. And this Caltech simulation is helping us figure out the physics behind all that extreme activity.
Right.
It's like having a front row seat to this chaotic dance of matter and magnetic fields near the event horizon.
You mentioned the event horizon.
Yeah.
Could you remind us what that is?
Sure. Think of it as the point of no return.
Oh, okay.
If you get too close to a black hole and cross that boundary, the black hole's gravity is so strong that nothing can escape.
Not even light.
Not even light.
Whoa.
It's like falling off a cosmic waterfall, but there's no bottom.
So it's like we're peeking behind the curtain of the universe's most spectacular light show.
Yeah.
And it's even wilder than we thought.
Way wilder.
This Caltech team has really opened up some incredible new avenues of research.
They have, and this discovery has implications far beyond black holes.
What do you mean?
Well, the fact that magnetic fields can have such a huge influence over something as massive as a black hole accretion disk,
Right.
it opens up a whole new world of possibilities.
I see what you mean.
For example, what about dark matter and dark energy?
Oh, yeah. Good point.
We know they make up most of the universe,
Right.
but we still don't really understand them.
Yeah, that's one of the biggest mysteries in astrophysics.
Exactly. Could magnetic fields be playing a role there, too?
That's a fascinating question.
It's a question that'll keep astrophysicists busy for a long time.
So we've gone from these flat crepe disks to fluffy angel cakes.
Yeah.
And we've uncovered the hidden power of magnetic fields shaping entire galaxies.
It's a lot to take in.
It is. Where do we even go from here?
Well, I think the first step is to take another look at our observations of black holes and their disks.
Okay.
We need to see if we can find more evidence of these magnetic fields at work,
Mm-hmm.
not just in quasars, but in other types of black holes, too.
So this is just the beginning.
Oh, yeah, just a tip of the iceberg.
A whole new chapter in our understanding of black holes and the universe itself.
Exactly. We've just scratched the surface.
It's exciting to think about all the new discoveries that are waiting to be made.
It really is. This discovery has opened up a whole Pandora's box of questions.
That'll keep us busy for generations.
Definitely. Yeah, it really puts things into perspective.
It does. You know, it's amazing to think that something like magnetism that we can't even see can have such a huge impact on the universe.
It's pretty incredible.
It makes you wonder what other hidden forces might be out there shaping the cosmos in ways we can't even imagine.
Definitely. And this discovery really shows the power of computer simulations in astrophysics these days.
I was just thinking about that, this whole simulation process combining fire and Starforge. It sounds so complex.
Oh, it's a massive undertaking.
Yeah.
Imagine trying to model the entire history of a city,
Okay.
from the very first settlers to the huge metropolis it is today.
Wow.
You'd have to account for everything: population growth, economic development, changes to the landscape, and how all those things interact over time.
That's a lot to keep track of.
It is, and that's essentially what they did here. They created a virtual universe inside a computer.
So they basically built a universe in a box.
Exactly, and they had to make sure it followed all the laws of physics, gravity, thermodynamics, electromagnetism, the whole works.
And they had to include these new insights about magnetic fields too, right?
Of course, it's like conducting a giant cosmic orchestra, making sure all the instruments are playing the right notes at the right time.
That's a great analogy. And the level of detail in this simulation, it's mind-blowing.
It's unprecedented.
Yeah,
Older simulations were like looking at the universe through a blurry lens.
I see.
This one gives us this crystal clear view. We can zoom in on individual stars and gas clouds swirling around the black hole.
It's amazing how far we've come with computational power. We're literally finding new ways to see the universe.
And it's all thanks to these brilliant scientists pushing the boundaries of what's possible.
They're not just theorizing anymore, they're building virtual universes to test their ideas.
Exactly. They're uncovering new mysteries every step of the way.
So where do we go from here with all this new knowledge?
Well, I think the first step is to re-examine our observations of black holes and their disks.
Okay.
We need to look for more evidence of these magnetic fields in action, not just in quasars, but in other types of black holes too.
So this is really just the beginning, a whole new chapter in our understanding of black holes and the universe as a whole.
Absolutely. We've only just scratched the surface. This discovery has opened up a Pandora's box of questions.
That'll keep astronomers busy for generations.
For sure.
Well, I think that about wraps up our deep dive into the fascinating world of black holes, magnetic fields, and all the mysteries that still swirl around them.
It's been a great discussion.
Thanks for joining us. And to you, our listener, we leave you with this thought. If a force as invisible as magnetism can shape the destiny of galaxies, what other hidden wonders might the universe be hiding in plain sight, just waiting to be discovered?